Hey, what's up everyone? Welcome back to another week of plugin critiques. It's week 3 of Obsidian October. I was away last week, but I'm back and ready to jump right into another plugin. This week we're going to be looking at Timeline View. Timeline View is a presentational plugin that creates a new view in the app that plots your notes along a timeline based on the value of one of its properties. It's akin to the Graph View core plugin. It provides a high-level overview of all of your notes with the ability to filter and group your notes based on a flexible criteria. Let's jump right into it and take a look at what this plugin has to offer. Let's jump into Obsidian, and from Obsidian settings, let's go to the Community Plugins tab, click Browse, and let's search for the Timeline View plugin. It's this plugin right here by b.camphart. We're going to install it and enable it. With the plugin installed, let's go ahead and open the timeline view. The plugin provides two ways to open the timeline view. There's a new ribbon icon in the top left that says Open Timeline View. There's also, if you open the command palette, a new command called Open Timeline View. Let's go ahead and select that. Okay, so my very first impression, I'm really impressed. Without much poking around, I can already tell that this plugin was made with a lot of care and that the plugin author clearly made a conscious effort to have the plugin feel at home with the rest of the Obsidian ecosystem. I see so much potential here. On the timeline view, you can see some familiar navigation controls on the right-hand side. These are reminiscent to the core plugin Canvas. If I open up a new canvas, you can see that there's a zoom in, zoom out navigation button. Similarly, there's zoom out, zoom in, and zoom to fit. And likewise, the timeline plugin provides this configuration menu that provides property, filter, and groups. This is very similar to the default Graph View plugin, which provides a very similar looking menu. If I press Command G, I can open it up and I can see a very similar looking menu here. But I just wanted to point out that these are not drop-in components that the timeline view is using. Instead, these are components that were carefully made by the plugin author to mimic the UI of Obsidian. You can tell that this plugin subscribes to the one thing well philosophy. It does one thing and it does it well, and it doesn't try to bake in too much functionality that feels overwhelming. That being said, this is not the perfect plugin and there's plenty of things for us to critique. Let's start by discussing the UI. So I have the plugin loaded up in my test vault, and I'm using a MacBook Pro with a Magic Trackpad to test. And the very first thing I noticed, which you might not be able to tell in the record, I'll try to zoom in as much as I can, but the timeline view itself is actually really blurry. And that's because whatever is rendering these elements to the screen is not expecting a high pixel density display, and that includes the MacBook Pro Retina display. Likewise, I don't think the plugin was ever tested using a trackpad. When I use a 2-finger scroll with the Magic Trackpad, it barely makes a dent in the scroll speed. I'm scrolling as fast as I can and the dots are barely moving. The Magic Trackpad also allows for 2-finger horizontal scrolling, and it doesn't seem like this plugin is expecting horizontal scrolling at all. When I scroll horizontally, nothing happens, and I can only horizontally scroll the timeline if I hold down Shift and scroll. I also want to point out two very minor UI annoyances. One is it seems that the navigation bar is missing the horizontal padding, whereas if you look at the canvas view, you can see that there's some padding on the right side. And second, these buttons do not have the same treatment as the native buttons in Obsidian. When you hover over them, they have a slightly different hover effect. This is a pretty large plugin, so even though each of those issues is small, it's going to be pretty daunting to make any of those changes without knowing where all of the code is. So let's not worry about any of the code just yet. Instead, let's start by looking at the devtools. To open up the developer tools, press Command-Option-I or Control-Alt-I if you're on Windows or Linux. And that opens up the Obsidian Developer Console at the bottom of the screen. Let's first figure out why the timeline view is so blurry. Let's use our element selector tool and hover over the timeline view. Immediately, I can see the problem. The timeline view is actually drawn using a canvas element. You can think of the canvas element like a digital mosaic. It's drawing elements directly to a grid of pixels. This is great for fast, detailed rendering, but it's built for a very specific size. So if you look at the devtools, you can see that this canvas element has a fixed width and height, and this is actually half the width and half the height that my screen has for actual pixels. These are instead the virtual pixels for the display. So to actually have this canvas drawn correctly, the width and height would need to be double, and then the entire canvas element would need to be scaled down using CSS. We're not going to be able to actually fix that without making changes to the code and how the canvas is rendered, but with a little bit of movie magic, I can fix that. We just need to refocus, and there we go. Okay, much better. Next, let's take a look at the navigation bar and fix the alignment. So first, we're going to open up the DevTools again. We're going to grab our element selector tool, and we're just going to click somewhere on this right sidebar. We're going to look for the root element that's rendering all of the buttons in this sidebar, and it looks like it's this menu element that's called timeline controls. So let's figure out how it's positioned. Scrolling down in the styles, we can see that it's positioned absolutely, and it's positioned using the top and right CSS properties. It also has a top margin. Let's just also give it a right margin as well. So now if we close the DevTools, we can see that it's aligned to match much more closely to the canvas. While we're looking at the navigation bar, let's also take a quick peek at the tooltips. These are created using Obsidian's tooltip library, which is actually looking for these elements with an ARIA label on them. So we can actually control the position of the tooltip using, if we look at the canvas really quick, using another property called data tooltip position. So this attribute, if it's found on the element, our tooltip library will actually take this as the preferred position for the tooltip. So if we just select this, and if we jump back over, and we're just editing things in the DevTools, so none of these changes are actually saved, but I just want to show you what these markup changes might look like. So if we edit in the DevTools again and press paste, so we have data tooltip position, and if we say equals left, and then we just blur it. So now if I hover over the element, you'll see that the tooltip is actually rendered to the left of the button. That's all I can show you from the DevTools alone. So without further ado, let's jump into the code and see what else we can find. So I have the project loaded up in Visual Studio Code. We're taking a look at the main.ts file, which holds our custom plugin class and is the main entry point into the plugin. When reviewing a plugin's code, I always start by reading through the onload function. This function is a lot more important than people realize, and it's a key contributor to Obsidian's overall load time. I know we just got to looking at the code, but we need to do a quick detour to talk about the Obsidian loading sequence. It's important for plugin developers to know how Obsidian loads because they need to know what's already been loaded before the plugin has loaded. The very first thing Obsidian does is it sets up the UI that's constructing the window, building out the basic components that are shared, things like the settings and setting up the theme and setting up your hotkeys. All of those are done first. The very next thing that Obsidian does is it loads plugins. It loads core plugins first, followed by the community plugins. Then it loads your data. Data means reading all of the files that are in your vault and loading any of the metadata that's available. Then Obsidian loads your workspace. The workspace is actually constructing all of the views that are in the app. That includes sidebar views, loading the file explorer, loading all of the open markdown tabs, loading any of the other properties, anything else. So if we just zoom into loading the actual plugins, what actually happens? First, Obsidian will read your main.js file. Then it'll execute the JavaScript inside of it. Then it'll initialize your plugin class. Then it actually loads your plugin. So when you load a plugin, first it calls the load function, which is a part of the base component class. But then it also, this is new in 1.7, it'll now await the onload function. And I bring this up because if we go back over to the plugin code, and what's important here, onload needs to finish executing before Obsidian can load the next plugin. So with that in mind, let's take a look at the onload function and see if there's anything that we notice that might be an issue or might have some performance implications. So let's work our way through the code and see what's happening. Looks like we are constructing a couple of helper classes. So let's see what's inside them. I'm just pressing down Command and clicking on them inside Visual Studio Code. This lets me just peek inside. So inside the constructor, it's just doing some basic assignments. Nothing here is particularly expensive, so I think this is fine. Next, we're creating the settings tab. So this is creating a custom settings tab, and we're just constructing it. Again, just assignments inside the constructor, so nothing expensive. And then we're passing in our settings tab to add setting tab. This is a function provided from Obsidian's API, and this is actually a registration function. So it registers the tab with the global settings, and it's what causes it to show up in the sidebar. It also, because it's a registration method, that means we actually are automatically removing the settings tab and cleaning it up when the plugin gets unloaded, so this looks all correct. Next, this looks like just a basic helper function that's wrapping the logic around set view state. Again, looks fine. Open timeline view looks like another just helper function. Another helper function. Next, we have the register view function. If you've never created a custom view in Obsidian, the register view function is basically a function that's creating a contract between your view type, which is just any string, and a function that tells Obsidian how do I create a view of that type. The view type here is just defined as view underscore type underscore timeline underscore view. That's pretty verbose. All of the core ones are just graph or markdown. So while it needs to be uniquely identifiable, this could just be timeline-view. Given that they need to stay consistent across updates, it's not something that the plugin author can now change anymore now that the plugin has already been published. And then the view creator is just taking the leaf and it's constructing the item view. So we'll take a deeper dive into the item view class in a little bit, but let's continue on in the onload. Next, add ribbon icon. Again, this is a registration function, so it's creating an icon in the left-hand ribbon, and it's automatically creating it with your given icon. This is the string that'll show up in the tooltip on hover. And then we have the mouse event handler. So what action should be performed on click. So again, this is cleaned up after itself after the plugin is unloaded. So nothing here looks out of the ordinary. And again, adding the ribbon icon is something I would expect to see inside onload. Next, we're adding commands. These are commands that are available in the command palette or accessible from the hotkeys settings where you combine them to a custom hotkey. Next, we're registering some events. This is the file menu event, which is fired on the workspace. So the file menu, if you're not aware, is a menu event that is fired when you right-click on the File Explorer, or if I switch over to Obsidian, inside a markdown file, you'll notice the More Options menu also shows options related to the file. And if I right-click on the tab, again, it shows these file menu events. These are all applied to the context menu when the file menu event is fired. So this all looks correct. Next, we're adding a listener for the auxiliary click on the window. So I'm actually going to totally ignore this code because I don't really endorse it. This is doing some overrides specifically for the tag pane. It's all accessing some private APIs. So let's move on and pretend we didn't see that. Next up, we have the editor menu. Editor menu is another event on the workspace, and it's fired when you right click. If I'm inside of Obsidian, if I right click on a line in edit mode, you'll notice that we have a new menu item that appeared. But if I look at the code here, something immediately sticks out. This event ref that's returned from on is not properly unloaded, and that's because we're not using register event. This is actually going to create a bug because the event listener is still going to exist even when the plugin is unloaded. So to fix that, we need to ensure that we are wrapping this result in our register event function. So this will fix that issue. Continuing on, we're registering this event. It's another event listener. It's listening for a private API. This is for global search. I'm going to do my best to avoid talking much about internal APIs, so we're just going to move on from this. And finally, there's just some code that allows for reloading the plugin in develop mode. So this looks fine as well. And we've now finished looking at the onload function. In general, I think this onload function is actually doing a great job. Other than that one small bug that we found, I don't really have any objections to it. I think it's pretty performant, and we can actually validate that by switching back over to Obsidian. And this is a new feature in 1.7. If I open up the settings and I'm in the general tab, if I scroll down to the bottom, there's a new setting that's notify if startup takes longer than expected. If I click on check now, this is actually going to show me everything about the startup information of Obsidian. And it's showing a bit of information about how long it took to load the vault, the workspace, and the core plugins. But it also shows any loaded enabled plugins. And that includes the timeline view, which just took 17 milliseconds. In my opinion, that's very good for a plugin of this size. This includes all the time it took to read, load the plugin code, and run and execute the onload function. Next, we're taking a look at the custom view class, timeline item view. Timeline item view extends Obsidian's item view class. If you are creating a custom view in your plugin, I highly recommend using either item view, file view, or editable file view as your base class instead of the default view. There's a few things that the view does that behave a little bit abnormally, so I would almost always recommend using item view when in doubt. Next, we have get icon. Get icon is just specifying the icon that'll show up in the tab next to your leaf. Get view type. Get view type, this is very important that this returns the same view type that's defined in your register view function, and that looks to be the case here. Next, we have the constructor, and this brings me to what I really want to talk about here, which is navigation. I suspect most people are not particularly familiar with this flag or understand how it works exactly. So let's just take a moment. Let's start by reading the docstring from the API. Whether or not the view is intended for navigation. If your view is a static view that is not intended to be navigated away, set this to false. For example, the file explorer, calendar, etc. If your view opens a file or can otherwise be navigated, set this to true. For example, the Markdown editor view, Kanban view, PDF view, etc. So I think that does an okay job of explaining which views navigate and which views don't, but I don't think it properly captures what this flag is doing. So let's start by just talking about navigation in Obsidian and how leaves and views interact with each other with regards to navigation. So switching back to Obsidian, I have a markdown view that's open and it's in edit mode. If I click on a link in a markdown view, the markdown view has been updated, and all of a sudden I'm now looking at the new note in this same leaf. So the tab updated, and I have a change to my leaf history. So I can press navigate back, and now all of a sudden my markdown view updated and I'm looking at the first note again. So when I click on the link, what's actually happening is Obsidian is looking to see if the current leaf is an eligible target for navigation. When it does that, it's looking at two things. Is the leaf pinned, and is navigation flag set to true? If the leaf is unpinned and navigation is set to true, clicking a link makes it an eligible target for navigating it away, and the tab will actually change. But if I just do the same thing and I pin the tab and I click, all of a sudden it'll open in a new tab. This is how markdown views work. And then similarly, if I go to the graph view, I can click on a note in the graph view and it'll replace the tab. If my graph view is similarly pinned, if I click on a note, all of a sudden the same functionality will happen. It'll open in a new tab and my graph view will stay as is. Conversely, what we have in the timeline view is if I click on a note, the timeline view is not considered an eligible target, so all of a sudden it creates a new leaf in a new tab. I think while the plugin author probably intended this to be the case and would consider this functionality expected, I think plugin authors, whenever possible, should try to stick to Obsidian conventions, and that navigation here should be true. So I just want to point out one more nuance to the navigation flag, and that's with regards to how the workspace updates when an active leaf has navigation equal true. If, for example, I have a markdown view open, you'll see that the links to the outgoing links show the outgoing links that are in my file. If I were to click in the File Explorer, and now my File Explorer is active, my arrow keys allow me to navigate around in the File Explorer, you'll notice that the status bar is still showing the proper word count and character count that match this markdown view, even though this view is no longer active. And the links in the sidebar are still also reflecting the Dark Forest links. So what gives? What's actually happening is that these views are actually responding to the file open event on the workspace, and the file open event only fires when the active leaf changes and when the new leaf has navigation set to true. So if I click around here, or if I were to click around and focus this sidebar view, that actually has not caused the file open event to fire. Instead, if I focus another markdown view, all of a sudden you'll notice that the links have changed, the word count and character count have updated, and that's because the file open event has fired. So if we now click on the timeline view and make that active, you'll notice that the status bar has not updated, the links have not updated. But if I were to open the global graph view, you'll notice that the status bar has cleared out, the links are active, and it's showing that this has no active file. So even though you might have a specific default behavior in mind when you click or how the view reacts, there is a little bit more nuance to the navigation flag. So if your view belongs in the main root split of the workspace, it's usually a better, more reliable default to have navigation equal true. Next, we have a custom scope that's being applied to our view. This is just allowing it so that when the view is active, our custom hotkeys can be applied. There's one hotkey, which is Shift Space, and that's bound to zoom to fit. I think this is actually a hotkey that's also shared with the Canvas plugin, so It's cool to see. Next, initialization, new promise. This, I'm actually not too sure what this is being used for. We'll continue on. Next, we have events. It looks like we're listening to a bunch of events on the vault and the metadata. Unlike our plugin, it looks like this is creating a list, and then we're iterating over that list and ensuring that each event ref is registered with the view. This is a bit fancy for my liking, but I guess it's a good way to ensure that all of your event refs are registered so that they're properly unloaded when the view closes. Next, prevent open file when. This looks like it's hacking into the Obsidian internals, so we're just going to turn a blind eye to that. Let's continue on. Open pane menu. So this, if I switch back over to Obsidian, this is adding menu options to the top right of our view. So we're creating some view options for view only timeline. Split right and split down are default, and then we have open linked markdown tab. So switching back over to the code, we can see that that first menu item, view only timeline, actually works as a toggle. It switches between view only timeline and edit timeline. For toggles, an alternative, while this is totally fine, an alternative would be to have a separate menu item, and we can say set checked, and we can have this be a toggle when view mode is true, and then view only timeline will be selected, and then when on click we can turn this into a toggle as well. So we'll just use a ternary here. So when mode is view, clicking this will switch it to edit mode, and when it's edit mode it switches it back to view. So this would be an alternative to all of this code here. So switching back to Obsidian, if I open the menu, you can see now this is a checkbox, and if I click it and open the menu again, now it's unselected. Next, we have this open linked markdown view. Looking at the code here, this looks either I'm missing something or this code is incomplete. What it's doing is it's creating a new horizontal split and just opening an empty leaf. So I'm not sure what this is doing, or maybe the plugin author just left this code incomplete, so I would probably recommend removing this menu item entirely. And lastly, we're calling super on pane menu at the very end. I recommend calling this at the beginning of the function instead. That way any default menu items or default sections get applied before you try adding any menu items. Next, we've got open note in linked leaf. This is just a helper function. Let's ignore that. Then compute display text, get display text, and set display text. So if you're not aware, the display text for a view is actually the text that's displayed here in the tab title bar, as well as in the tab display itself. So if we see what's happening here, it looks like the view is actually doing something kind of hacky to ensure that the title bar gets updated whenever you compute a new query. So if we go into the view and open up here and jump into filter, you'll see if I search, it's updating here and here. This is using some internal APIs, so I'm not going to advocate that plugins do something like this. It's very likely that it could break in a future version of Obsidian. Continuing on, we've got set state and get state. These are actually very powerful functions that are part of the Obsidian API, and they are how a view gets serialized and then eventually loaded from the workspace.json file. So why don't we just take a look at our workspace file for my test vault. So the workspace.json file actually has a serialized version of every open view in the workspace. So if we scroll through, we can see it's actually a pretty comprehensive file that defines the layout of the workspace, as well as all of the open tabs and the latest state that they're in. So if we look in the workspace.json file for our view type timeline view, we can see that the state has our scroll value, the mode that we're in, our scale, and a bunch of settings. I just want to point this out because then anytime you open Obsidian, all of this serialized data is going to then go back through the set state. So this state that's unknown is actually going to be passed in from the JSON file, and it's up to you to parse and deserialize it and determine how you want to restore your view to that serialized state. From what I can tell, Timeline View is actually using set state and get state very effectively, so I just wanted to point that out because I don't know if there's enough plugins that are aware of this API and how to actually structure it. Moving on, we have onOpen. OnOpen is called immediately when your view is open, and this is usually where plugins are going to be setting up their actual DOM components. Right off the bat, we're grabbing our content element and we're reaching into the container element's children and finding the content L. This might have been in the public documentation for a little bit, but I want to just point out that content L has a reference, so I recommend switching that to use content L directly. Continuing on, the rest of the onOpen function is creating this note timeline component. The note timeline component is actually built using Svelte. Svelte is a front-end library that I'm quite fond of myself, and I use in a few of my own plugins, but it is outside the scope of this plugin critique, so we're going to avoid digging too deep into Svelte code. Just know that it's a really solid alternative to something like React or Vue. It's very lightweight and event-driven, so it's perfect for something like a Obsidian plugin. When using any of those front-end libraries like React, Vue, or Svelte, usually there's some type of runtime involved, and that involves a lot of extra overhead and some memory management. So it's important that whenever you're mounting a new component, you also are using the corresponding code to clean up after itself. So let's just jump down to our onClose function and look for this component. So we're in the onClose function, and here's this component, and see we're using the destroy method, which is coming from Svelte, and this is properly detaching the component and unloading any of the associated event listeners. So that's actually the last of the timeline view that I want to show you guys. The rest of the code is really just setting up the Svelte component, and all of the actual code that's loading and building the timeline is in Svelte. So I don't really want to show off that. The next thing I wanted to show, I want to give the timeline view a final little demo for you to see how powerful and really how much potential this plugin can have. So I want to show a timeline view of all of the latest Obsidian releases and have them plotted by the time that we actually published that release. That way we can take a look, see if there's any interesting patterns into the release intervals, the release frequency, or we can just use it as a quick way to navigate around and jump into individual releases. For that demo to work though, I think we need to fix a couple of small bugs. First, I noticed that while I want to use the published property, which is the datetime property that I have configured on all of my notes, I noticed that that doesn't seem to work, and it's not properly plotting the datetime across the timeline. So let's figure out what's going on there. Back over in the code, I found this helper class that has a function called select value from note. And from what I can tell, this seems to be the function that's responsible for converting a note's properties into a value that can be plotted across a number line. The problem is we're looking at the properties from the YAML, and so we are going to need to convert our date time, which is just stored as a string. We're going to need to convert that into a number that we can plot. So in order to actually do that conversion, let's use the date library that's provided through the Obsidian API. We pass the value into moment.js, and then this will actually create a moment object, which we can then try to parse and validate, and then ultimately convert into a numerical value. So if the date time is valid, let's return the Unix timestamp. So switching back over to Obsidian, okay, here are my notes, and it seems maybe better. They're plotted across the date a little bit better, but they're all bunched up. It looks like there are a couple of outliers. Let's click into these notes and see what's going on. Okay, so these are notes that do not seem to have a published date associated with them. So let's just get rid of them. I think ideally it would be really nice if the timeline view ignored any note that didn't have a particular property, but I think that's just going to have to be a feature request for now. Now that we've just deleted those two notes, let's see what our timeline looks like when I zoom to fit. Amazing. It looks like all of our releases are now plotted correctly based on the date time value. So for that final glow up, let's try using and testing out the group feature. Here are all of our releases now grouped by the major release version. So 1.5, 1.6, and 1.7. Hey everyone, that concludes this week's plugin critique. A huge thank you to B Camphart for submitting the Timeline View plugin for critique. And if you liked this content and would like to see more of it, be sure to subscribe. There's going to be one more plugin critique video for the Obsidian October series, and that's going to be coming out sometime next week. Thanks. Bye.